It happened 13 times. 13 times from 1993 to 2009, scientists dumped iron sulfate in the eastern equatorial and northern parts of the Pacific Ocean, as well as in the Southern Ocean. The amounts were significant, and such experiments triggered a strong reaction from critics, not just SOFA critics, but real ones too. So strong that in 2008, the UN Convention on Biological Diversity got involved. After an investigation, they called for a moratorium on these experiments until there is an adequate scientific basis on which to justify such activities. The resistance was so strong that scientists just couldn't find any funding. The dumping of iron sulfate into the ocean stopped. However, in 2012, businessman Russ George from California did something that scientists couldn't afford to do. He illegally dumped a huge amount of iron sulfate into the Pacific Ocean. And when I say huge amount, I mean 100 tons. This happened off the west coast of British Columbia, Canada. As a result of this discharge, a massive phytoplankton bloom started, covering an area of 3,900 square miles. It was so extensive that the bloom was visible even from space. See for yourself. These yellow and orange areas show a relatively high concentration of plankton. The photos were taken in August, right after the July dump. And this commercial dump was 100 times larger than any previous experiment in ocean iron sulfate saturation. But what's the point of all this? I'll make myself some coffee, and then I'll tell you. Today's going to be interesting. Just an unobtrusive reminder not to forget to hit the like button if you do that sort of thing. So let's start with one simple fact. The global ocean is keeping global warming at bay. For decades, they've been softening the effects of climate change, though many people on Earth don't even realize it. It turns out that the world's oceans absorb at least a third of the carbon dioxide released into the atmosphere from human activities. And they've been doing this since the Industrial Revolution. That is, since the 18th century. So absorption has always been happening. But it was during this period that the amount of carbon dioxide increased significantly. Today, we know that the ocean can store about 19 times more carbon than can be stored on land. It's much more spacious. And here comes a reasonable question. Can the ocean absorb carbon dioxide in slightly larger quantities, since the volume seems enough? The answer is yes, it can. However, it can't happen on its own. It will require intervention in the chemistry and biology of the ocean to increase the amount of carbon it absorbs. But don't you think this sounds like something potentially dangerous? Something that could lead to a disaster? Back then, critics who were against the scientists' experiments were also very concerned. They believed that adding iron sulfate to the ocean could cause toxic algae blooms or even create dead zones in the ocean. The reasoning is straightforward. Too much phytoplankton in one spot will produce large amounts of methane as it decomposes, and methane is a greenhouse gas. But they didn't realize this right away. It all started when an American oceanographer proposed an experiment back in the 1980s. He observed that dust containing iron, which gets transported from continents into the ocean, led to massive phytoplankton blooms. Why not try doing the same thing ourselves, thought the scientists, and soon the first experiments confirmed adding iron makes the ocean bloom. However, the iron dumps were too small and too brief to determine how much carbon dioxide was removed from the atmosphere due to the blooming. It's actually pretty simple. Tiny marine plants take in carbon dioxide from the air, and they can have a big effect on climate change. Plus, adding iron helps these plants to grow. More plants, more carbon dioxide is taken in, more benefits for the climate. In theory, there could be so much phytoplankton that it could cool the entire Earth. Not to zero, obviously, but to a regular temperature, like what the planet had before global warming began. Usually, the amount of phytoplankton changes by itself. For example, it increased after a volcanic eruption, an event where iron is naturally dispersed. And no, that California businessman wasn't worried about the planet's climate problems. His goal was to boost the salmon population. The logic was simple. A lot of iron leads to more phytoplankton, which in turn could lead to more salmon. Although no one said it would actually work that way, the businessman was unstoppable. By the way, he had already tried dumping this plankton food near the Galapagos and Canary Islands. Since then, the governments of Spain and Ecuador have banned his ships from entering their ports. And since 2012, there have been problems with American authorities as well. And it's not just that the dumping was illegal. Actually, there are quite a few opponents to such iron seeding. The Massachusetts Lobstermen's Association claims that additional work needs to be done before truckloads of liquid alkaline can be dumped into the ocean. They're actually against sodium hydroxide, but it should work just like iron sulfate. And it's hard not to agree with the lobsterman. That is, phytoplankton might be doing fine, but it's quite possible that this could deal serious blows to commercial and recreational fishing. And that, in turn, would hit the economy, not to mention the problems for ordinary people. The international organization Friends of the Earth is also against it. They remind us that the UN has actually imposed a moratorium on such ocean manipulations. Environmentalists also emphasize that sodium hydroxide is an incredibly dangerous substance that causes chemical burns if it comes into contact with the skin of people or marine animals. By the way, the locals are also not excited about this idea. There have been concerns about the impact of all that on the environment for a long time. But there's incredibly little data on the consequences. Critics say that changes in water properties might cause ripple effects in ecosystems. For example, stimulating phytoplankton blooming could change local food chains or even lead to the formation of greenhouse gases. Anyway, I've already talked about this. And of course, there's a risk to the local wildlife. But while people are actively resisting, scientists are insisting we need to act as soon as possible, like right now. We should have started yesterday. People created a climate model and found that the window for reducing global warming just by reducing carbon dioxide emissions is closing. To put it simply, we have very little time to solve climate problems by dealing with carbon dioxide alone. After that, we'll have to do a whole lot more. And to make it by the year 2100, when this window closes, we need to start actively removing carbon from the atmosphere right now. Removing it in such a volume that it can only be done with the help of the ocean. There are no other options. It would have been nice to start all this much earlier, but as you remember, back then, the experiments were quickly shut down because there wasn't such an urgent climate crisis, unlike these days, and denying it is simply impossible. Now scientists are working under completely different conditions. For example, they received nearly $2 million for funding a 3-year research project focused on iron fertilization and its consequences. Compared to the zero funding in the past, it's almost like a jackpot. And yet, for the near future, they are not planning to dump the iron. The technology is still not ready for mass use, although it's believed that such ocean fertilization could remove between 0.1 and 1 billion tons of carbon dioxide per year. So soon, researchers plan to release 6,600 gallons of sodium hydroxide, which is also called caustic soda or lye, into the ocean near Cape Cod. By diluting chemicals in the water, they'll try to increase the ocean's ability to absorb carbon dioxide from the air above it. If all goes well, we might have a recipe for dealing with global warming, but marine life won't be harmed. Well, at least there shouldn't be any long-term negative effects. And apparently, if scientists weren't sure that the ocean would handle such infusion, well, they wouldn't even be doing these experiments. What about burns, you might ask? Well, scientists have an answer for that too. They say the project will operate in a pH range considered safe for aquatic plants and animals, and the alkalinity will be constantly monitored to make sure exactly no one gets hurt. The experiment is set to start this summer 10 miles south of Martha's Vineyard with those same 6,600 gallons. If all goes well, a larger scale test with about 60,000 gallons of chemicals will take place next summer in the Bay of Maine, northeast of Provincetown. Without extra stimulation, carbon dioxide can stay in the atmosphere for centuries before it's absorbed by plants or incorporated into the molecular structure of rocks, and the rates of emissions from burning fossil fuels and other human activities are so high that no natural absorbers can handle them. And the ocean's ability to absorb human-made carbon dioxide emissions is gradually decreasing, and we simply need to, if not stop it, at least slow down this decrease. When carbon dioxide dissolves in seawater, the resulting carbonic acid leads to increased ocean acidity. This impacts marine life, and the effect isn't exactly positive. That's when sodium hydroxide comes into play. Adding it should reverse this process or at least soften it. It's kind of like giving the ocean a heartburn pill, because acidification is a real problem. It's increased by 26% since 1850. And that's almost 10 times faster than any other period in the last 55 million years. It's not like we have precise data for the whole period, but we can still make certain conclusions. And you know what? Actually, the ocean knows how to deal with its heartburn naturally, just like the human body does. When rain and wind erode mountain rocks on land, the rocky grains break down and end up in rivers, lakes, and groundwater. From there, they gradually move into the seas and affect the acidity, just like the alkali that gets dumped. It's just that natural erosion of rocks takes thousands or even millions of years. Taking a pill is still faster. However, this entire plan has a flaw. Even though scientists assure us that fertilizing the ocean won't have any negative consequences, there are strong reasons to think it could end in catastrophe. British meteorologists analyzed historical records from 1900 to 2010 and found that fairly strong volcanic eruptions in the northern hemisphere preceded 3 out of 4 of the driest summer seasons in the region. Historically, powerful volcanic eruptions have always been linked to climate change. For example, after the eruption of Mount Tambora in what's now Indonesia in 1815 came the infamous year without a summer in 1816 in Europe. Crop failures, famine, disease outbreaks. After the eruption of Mount Pinatubo in 1991, what followed was what climatologists later called the Pinatubo effect, noticeable global cooling in the years that followed. It would seem that where are the volcanoes with cooling and where are the world's oceans in drought? The thing is that dumping chemicals into the water is one of several geoengineering attempts aimed at slowing down climate change. There's the second option, the release of aerosol particles into the stratosphere to significantly dim the sun. Today, scientists are experimenting with a device built on the roof of a decommissioned aircraft carrier in the San Francisco Bay. They're trying to add salt to the clouds over the ocean, which could theoretically reflect sunlight back into the atmosphere and keep Earth's temperature lower. It's similar to cloud seeding, but they've called it brightening. There are also critics of this idea, such as the US government and Greenpeace, because attempts to deal with the climate change by altering the atmosphere could have unpredictable consequences. They might even trigger a disaster in a drought-prone region of Africa. In any case, that's what researchers suggest. Geoengineering is a really intricate topic because any intervention in the natural order of things on a planetary scale, well, let's just say it risks ending up very badly, including the experiment with the ocean. So it requires a very, very thorough study of the issue and all possible consequences. Checks, checks of checks, and even more checks. In short, everything to make sure our actions don't lead to disaster. Let's paint the ocean. Every year in winter, the Arctic Ocean gets covered with bright white sea ice that helps reflect some of the sun's heat back into space. Well, we all know how white color works. But this reflective surface is getting smaller and smaller each year, so scientists suggested artificially whitening the ocean. Yeah, I'm serious. Among the proposals put forward by them is injecting microscopic bubbles into the water, possibly with the help of specially equipped boats. These bubbles are supposed to make the surface whiter. Another option is to use floating granular materials, which would also reduce the amount of solar heat absorbed by the water underneath them. And I hope I'm not the only one who's now imagining the sea covered in cat litter. Let's sink the seaweed. Compared to painting the ocean, this idea looks pretty good. Macroalgae are plants that grow in water and grow really fast. Some types grow several inches a day. And all they need to do this is absorbing carbon dioxide from the ocean. When seaweed dies, it sinks to the bottom where carbon can either circulate through deep-sea food chains or be buried in sediments, staying there for decades or even centuries. That's enough to prevent it from affecting the climate. So the idea recently proposed by scientists is let's grow seaweed on floating platforms and then sink it to the depths. This will only work if the grown plants really end up on the bottom. If they're eaten or, for example, used for biofuel, the collected carbon will return to the atmosphere. Let's use moon dust. Proposals to fight climate change by blocking sunlight are not new. What is new is using dust for this purpose. And not just any dust, but dust from the moon's surface, simply by launching it in the right direction. If you launch a cloud of moon dust on a specific trajectory, it could block about 1.8% of sunlight. But for this, you'd need a massive amount of dust, 22 billion pounds a year, and apparently a huge broom. The UN is really concerned. Recently, the UN published a report warning that some efforts to tackle the effects of climate change might bring additional risks. It's not exactly a secret, but the report especially highlights how interconnected and fragile our ecosystem is in the 21st century. The report highlights two major issues: insufficient research and distortion of facts. The UN calls on everyone to think about the future and all that stuff. Well, thanks, I guess. Since you're here at the end of the video, hit the like button. See you later.